All right, we're going to talk about the Chapter 4 review worksheets. The first one is the masses of atoms worksheet, so I'm just going to start down here at the bottom. It says a mole is a certain number of items. What number does each of the following represent? A dozen would be 12, of course. A million is 1 with 6 zeros behind it. A gross is a dozen dozens, which is 144. A billion. And then a mole is 6.02 times 10 to the 23rd. Number 2, it says using a laboratory balance, measure and record the mass of 1 mole of each of the following elements: carbon, iron, zinc, and copper. So iron, we're going to have to look at the periodic table. And you can see iron has an atomic mass of 55.845. So iron's, the mass of 1 mole is 55.845. Then the next one, carbon. I guess I should have started with carbon. Carbon is C. And it has a mass of 12.0107. And those are grams. Then zinc is Zn. Zinc is right here. It has a mass of 65.409. Grams. And then copper is Cu. Copper's right here, has a mass of 63.546. Then on number 3, it says find the mass in grams of each of the following: 2 moles of aluminum. So we're going to take the atomic mass of aluminum, which is 26.98. Times 2. And you get 53.96 grams. For magnesium, the atomic mass is 24.305. Let's just call it 24.3. Times 4 moles. It's 97.2 grams. 3 moles of helium. 4.002, let's just call it 4. So 4 grams times 3 is about 12 grams. Then how many moles are in each of the following? So 156 grams of chromium. We're going to have to take 156 grams divided by the mass of 1 mole of chromium, which is 50, I'm going to call it 52, 51.996. So 52. And I'll do the math here in a second. 156 grams of potassium, so 156 divided by, potassium has an atomic mass of 39.09, let's call it 39.1. And then 119 grams of uranium. Uranium has a mass of, right here, 238. So 119 divided by 238, and this is going to give us the number of moles. So 156 divided by 52 is, this is 3 moles. 156 divided by 39.1 is 3.98. I'm going to call it 4 moles. 119 divided by 238 is 0.5 moles. And so let's flip this over and do the same thing on this section. So I'll need to erase what I've got here. All right, it says the electron has very little mass compared to the proton or neutron. The mass of the atom depends on the nucleus and how many protons and neutrons it has. The sum of the protons and neutrons is the mass number of an atom. The number of neutrons in an atom can be found by subtracting the atomic number from the mass number. The mass of the atom is so small that there is a measure called the atomic mass unit. So I'm going to erase this and move it up. We'll do the bottom part. It says the nuclei of all atoms of a given element always have the same number of protons. They will also have the same number of electrons around the nucleus. Some atoms may have more or fewer neutrons than will other atoms of the same element. Atoms of the same element with different numbers of neutrons are called isotopes. Hydrogen has 3 isotopes. A hydrogen atom may contain 0, 1, or 2 neutrons. Every atom of carbon must contain 6 protons. I thought it was 6 protons. But some contain 6 neutrons, and others have 8 neutrons. Some elements have only blank natural isotopes, that's 1. However, other elements may have many isotopes. One way of showing the difference between isotopes of an element is to put the mass number after the name of the element. The second way of showing an isotope is to write the mass number and the atomic number with a symbol of the element. In nature, most elements are blank of isotopes. They're mixtures. In chlorine gas, there are 2 isotopes. The average mass of this element is blank the 2. That should be between 2. So I'll do a video of the second worksheet here in just a few minutes.